Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's video we're going to look at a simple tool improvement. Sometime back, Bruce Witham posted on the YouTube machinist group this one right here, if you're not familiar with it. But Bruce posted on there one of his ideas. Bruce used to post some videos on YouTube. I hadn't seen much from him lately, but he does post right regular on the Facebook group, and occasionally he'll post one of his tips, which are usually pretty good tips to follow and pay attention to. A recent one, though, dealt with an improvement he made to some V-blocks. Now his, I think, were probably considerably bigger than these. These are 5-inch right here, 5-inch by 2 inches wide. I think his were probably closer to 8 or 10-inch, possibly even 10-inch wide V-blocks. I bought these to use primarily on my welding table. They're a bit big for my milling machine, but I use them on the welding table, and work holding is as important on a welding table, or can be as important on a welding table as it is on a mill or a lathe. And his idea was to drill and tap some holes in these cast V-blocks. These are cast, but drill and tap a couple holes in them for a hold down bar, a crossbar. So that's what we're going to look at doing today. I'm going to mount these over on the milling machine, get them set up, and we're going to drill and tap some holes in them, and then later in the video we're going to actually machine out our crossbars for the work holding itself. All right, I have the blocks in the mill vise now, and they just barely fit in there. As I said, these are 2 inches wide, so the two of them together is 4-inch, and this vise opens up to just a little more than 4-inch. But the waviness you might see in the picture over here is just where I clean these blocks up with the Scotch-Brite pads. As I say, I use these primarily on my welding table, so they had a little bit of surface rust on them, but cleaned that up with the Scotch-Brite pads. What I'm going to do first is find this back corner back here with the edge finder. Zero the y-axis and double check it. All right, that's good. Now I want these holes centered, in this case on the y-axis. Since these are 2 inches, first off I'll come in half the width of the probe, which the probe is 200 thousandths, so I'll come into at 100 thousandths and re-zero out my y. Now I'll come in 1 inch. All right, and I'll go ahead and lock the y down at that point, and I'll zero it out on the DRO as well. Now let's come over here to this edge. All right, I'll zero out the X there, and we'll try it again. We'll double check it, and that repeated. Now what I'm going to do, I'm going to come in 0.4375. What I'll be using for the hold downs on this is from my regular clamping set that I use here on the mill. I'll be using these 3/8/16 bolts. So what I want to do is come in from this edge, 0.4375. That will give me a 1/4 inch of material left out here after we drill and tap our holes. So let's come in 0.4375. All right, I'll zero out the DRO at that point as well. Now what that has for us now, possibly you can see this, this is our long ways. This has our 0 point set right here. We'll drill this one first, then we'll move over 4¼ inches, drill this one, then we'll drop down 3 inches, drill this one, move back 4¼ to that one, then we'll move back up here and tap each one of them. If I didn't have a DRO on the machine, I would probably do all the work at each position, but DRO, I should be able to repeat the positions. So we're going to start with the tap drill for a 3/8/16. I tell you what, let's go first with the starter bit here. I'll go around to all 4 positions and start the hole. And as I said before, this is cast material, so it shouldn't be hardened. All right, now we'll move over 4¼ inches, 4.125, 4⅛ inches. Now we'll go back 3 inches on the y-axis. Well, that's not right. We'll go back 2 inches. All right, let me explain right quick. I just marked that down wrong. We've got 2-inch block and a 2-inch block. We're offsetting 1 inch from this side. We want to offset 1 inch from that side, so 4 minus 2 is 2. And so now we're back in business. Now we'll bring the X back to 0 on the DRO. I do like this new power feed that I put on this mill. If you hadn't seen those videos, go back and watch both parts of that. I think it'll be worth your time. All right, now while we're sitting right here, we can go ahead and drill this hole. And as I'm sure you've heard it pointed out in many of other people's videos, and I have mentioned it as well. When you're drilling cast iron, you really don't need lubricant. The carbon in the cast iron serves as a good lubricant. When I tap it, I may put some lube in there just primarily to help excavate the chips. All right, we're going to set the DRO, Z-axis DRO, and I'm going to go down probably 3/4 inch. That may break out just a little bit in this webbing in here. This inside web, as best I can measure, is about 1/4 inch. So this, for maybe 1/8 inch, may break out a little bit, but I'd rather have it plenty deep over here on these sides. Let's slow that down just a little bit. All right, there's 3/4 inch. Now we'll bring the DRO back to 0 on the y-axis and go down our 3/4 again. Move over our 4.125. Move over our 2 inches. Definitely have to be cleaned out down in the hole, but what we're going to do next is put a little bit of a relief on this top edge here, chamfer if you will. This is a blind hole. I'm going to go ahead and I'm going to do this in 2 steps. I'm going to use my taper tap to begin with. And I'm going to put this in low range, low speed. And as I said, I'm going to use a little bit of tapping fluid on this, even though it is cast. Now, what I'm going to do with this, since it's just to show a different way of doing it, I'll do the tool change at each position instead of going through all the positions with the same tool. So now I'm putting the bottom tap in. A little bit of rapid tap. Move over our 2 inches. And I think just for the sake of trying it, I'm going to try with the bottom tap to begin with. Cast iron is considerably softer than steel, of course, so it may go ahead and tap this all the way to the bottom without starting with the taper tap. I think it'd really rather have that taper tap first. All right, I think we got all 4 of our holes drilled and tapped. All right, I'm going to get some flat bar. Look at my stock over there, find some flat bar, and we'll lay out for to make the cross lockdown pieces. All right, I found some 1/2 inch by 1 inch material in my supply. Probably could have used something a little thinner, maybe 3/8, but this will be fine, I think. I've cut 2 pieces a little over 5 inches long, which is the width of the V-blocks is 5 inches. I'm going to come over here to this side and clean them up to length, or clean them up together on this side over here. All right, that's got that in, those ends cleaned up good. Let's move down here to this end. We'll make a couple passes, whatever it takes to get them together, and then I'll do a measurement. I think I might be, could be as much as a 1/4 inch over. All right, let's get a measurement. You notice I got the 2 pieces stacked here, and even though they were cut off the same piece of stock, they should be the same size. But I've got these pieces of aluminum soft wire here, just to be sure that the vise grips both pieces. All right, so we need 184 thousandths off. I will 0 the DRO, and I'm just going to keep working on this to get that 184 off. And I did verify that this end is staying in place. So I'm going to get the get the end mill out, get the drill chuck back in. All right, I got the burrs cleaned off of this top piece. What I'm going to do now is use the edge finder again and find the center of our work pieces here. Come to the other side. I zeroed out the DRO, so we'll come to the other side. Guess what? I zeroed out the wrong axis. So we'll come in here. Let me get off that edge just a little bit. And that's the y-axis. I'll zero that. All right, and then y 1/2. And I'll lock the y-axis down right there. Now, if we recall, well, let's see. Let's find this outside edge first. All right, that repeated. Remember, our probe is 200 thousandths, so we want to move over 100 thousandths. We'll zero out the x-axis. Now, remember when we were doing the V blocks, we stepped in 0.4375. So we want to do the same thing here. And we'll zero out the DRO one more time. I think what I'm going to do on this is drill with a 25/64. So that's a 64th over the 3/8 bolts that actually be going through. But I'm going to do that in 2 steps. Grab actually in 3. I'm going to start with our centering drill. And just like we did on the V blocks, we'll come 4.125 in between the holes. Now we'll put our 1/4 inch drill bit in. All right, I think while we're right here, I'll go ahead and drill our 25/64. Santa Claus should have brought me a new drill chuck. I've pretty much worn out the jaws on this one, letting taps and other hard items slip in the chuck. Now we'll come back to 0 on the DRO. All right, now I think what we'll do is carry these pieces over to the surface grinder. Well, actually what I probably do first is go over to the drill press and countersink these holes on all 4 sides, or on both sides of all 4 holes. All right, let's see if we can deburr each of the holes. Now I think we're ready to go over to the surface grinder and get this mill scale off. Okay, I'm over at the surface grinder now. I got our 2 pieces down on the mag chuck, and I think we're ready. What I'm going to do is surface grind these 2 edges, flip it over, do the other 2 edges, and then do the sides the same way. We'll get a little coolant flowing on it. And I'm looking for a touch off now. And we're just barely touching now, so I'm going to keep working this couple thousandths down each time until we're cleaned up. All right, we're cleaned up now. I'm going to take 4/10 off or 5/10 off, half a thousandths, and only step over 50 thousandths at a time just to put a finish. Usually when I set something up like this on the side, especially where it's got this little bit of a rollover uh, from the, I'm pretty sure this is hot roll, but I usually would use my magnetic transfer blocks, but they're the same height as this. So I'm just going to use just a piece of steel down here on the end and a piece on the side here, just as some extra holding power. So let's give this a try now. This is going to take considerably more grinding because, like I say, there is a little bit of a roll. All right, I've got all the sides and the edges surface ground now. I'm going to get the chamfering block set up and bring you right back for that. Okay, I got the chamfering block locked down now, or I got it in place and I got the table locked down. All right, hopefully you can see. Camera will focus. Got a nice chamfer on all four of the end edges, and also the long edges. I'm going to do the other piece the same way, then we'll meet back over the workbench and recap this video. All right, we got our two V blocks drilled and tapped. We also got our lockdown pieces drilled out. And as I said earlier, I can use the hardware directly from my mounting kit that I have to go with the mill. In this case, I'm just going to put them on one side. And we can take something like this piece of round stock, cradle it in, and just like anything else, you don't have to use the hand of God to tighten that down. I would, in a real situation, I would tighten it down a little bit more than hand tight. In this case, I'm only going to put one on, hold it down. Then we could take, as I say, I use these mostly on my welding bench. Take something like this strong hand, put it up, hold our piece, and loosen it just enough to turn it like we want it to do our welding. And we've easily held our piece in place. It's not going to roll, it's not going to slip. If we wanted to, these do have holes through them. If we wanted to put bars in between, we could. I know Bruce said in his example that he drilled his out so he could put threaded rod between them to hold them at set spaces. But I think that's going to be a good addition to these 5-inch V blocks. I hope you've enjoyed the video. Take care, and we'll see you on the next one.